Welcome to ZEISS Academy Metrology. My name is Luis Henschke and I'm a certified ZEISS CALIGO trainer. Today I want to show you a double column coupling of a horizontal arm measuring machine together with ZEISS CALIGO. A double column mode is needed for car body measurements, for example, to increase speed and flexibility of the measurement. This video shall give you some background information how the therefore required double column coupling is done successfully. At first, two single columns must be ready to use in CALIGO and therefore installed. That means also these single columns must be qualified separately before the coupling can be done. If these requirements are fulfilled, we can move further. As already mentioned, qualification must be carried out before the coupling. Please use the reference spheres belonging to the machine and also attach the temperature sensors if available. These sensors should be positioned as close as possible to the reference sphere. When the qualification of both columns is completed, we can start with the coupling. I now have already started CALIGO. In the next step, I will open a new working session at first. This one is loading at this moment. Before we can do anything in this car body session, let's first go to the settings. There we go to Tools and Settings, then to Devices and open the plus. Here we see all available columns that have already been installed. When in single column mode, column 2 is in operation. The check marks are set for connection at system start and for simulation of the controller. Of course, simulation of the controller only makes sense if you have a simulation machine available and you currently want to use it. For the actual operation of the machine, only the checkmark connection at system start may be set. For a double column operation, of course you have to add a second column. This is column 1. We will now also set these checkmarks for column 1, connection at system start and simulation of the controller. When we have done this, we can close the settings and then have to restart CALIGO. This is necessary to load the settings we have already made and make them available in CALIGO. Before we get deeper into the double column coupling itself, I would like to give you some background information. In order to be able to illustrate this a bit better, I would now like to switch to a whiteboard. If you have a simulation of the machine available, you can also display the double column coupling in CALIGO. As you can easily see in the picture on the right, it is possible that the two single columns could collide with each other in the double column coupling. Therefore, it makes sense to buy a collision protection as well. This protection is switched off by default though. In the simulation, I can show you this very easy. The collision protection is given in head coordinates, is measured from head to head and is freely definable according to your wishes. Anyway, the distance should be at least so big that the two reference probes cannot get in each other's way. What is important? Nevertheless, the measuring areas of the two columns can overlap. They just can't approach beyond the range of the protective sphere. You can practice a double column operation with only one computer or with two computers. Advantage: if you work with two computers, you can also use the two columns separately as single columns. Of course, you can do this also if you work with only one computer, but then, however, one single column remains unused. In double column operation, column 1 is the master machine and column 2 is the slave machine. Since the configuration with two computers is more common, I would like to discuss this in the following and refer to the right picture. Here, control is only done by the master PC and CALIGO may only run on the master PC. The slave PC only runs along, just like the slave column. Therefore, all columns must be deselected on the slave PC. After that, CALIGO must of course be closed there, otherwise no operation is possible. Let's summarize once again. CALIGO must only run on the master machine and the master computer. Both columns are controlled from the master computer. Now that we have completed the basic theory about the double column operation, I would like to proceed to the actual coupling. The actual coupling is done by an already predefined program, which is automatically supplied with the installation of CALIGO. In the next step, I would like to show you how to access this program. First go to Drive C on your computer, then to User, Public, Public Documents, then to Caligo, to Inspection, and you will end up in this folder. Here we have 3 coupling programs available. They differ in how many reference sphere positions are used. When first setting up your machine, you must work with at least 3 or 5 reference spheres to make a translational and rotational fitting possible. Later on, when you update the coupling regularly, coupling with 1 sphere will also be sufficient. I would now like to show you the coupling program with 3 reference spheres. That we can better understand the double column coupling with 3 spheres, I have schematically illustrated the setting once again. We now look at the measuring plate from above. You can see column 1, the master machine, and column 2, the slave machine. The reference spheres should be distributed as widely as possible on the measuring plate. Not exactly on the center line, but also eccentric from the center line. This is important to make possible not only a translative, but also a rotatory fitting. Then the probing is to be carried out. At first, sphere 1 with column 1 and column 2 is probed, then sphere 2, and finally sphere 3 is first probed with the master machine and then with the slave machine. Now we look sideways at the measuring plate. Here it is easy to see that the spheres must be placed at different heights. In the end, they have to build a plane. Only then a rotatory fitting is possible. It must also be ensured that the reference spheres are not arranged in an inclined position, as this would cause them to form a straight line. A sphere up here would therefore be not good. It is important that the plane is shaped by the different heights. We now start the coupling program in Caligo. After opening the coupling program, I would now like to go more into the details about the content of the measurement plan. Here we will take a look at the main measurement plan. We can see that 6 spheres have been created. 3 spheres for the probing with master machine and 3 spheres for probing with the slave machine. Afterwards, the coupling takes place. A reasonable way to probe a sphere would be to start at the middle with the pole point, then touch probing point 2 on the other right, touch point 3 at the top, touch point 4 on the left side, touch point 5 at the bottom, and then return to the pole on the sphere. At least 4 probing points are required for a sphere, but for a higher accuracy, 6 probing points per sphere are programmed in our coupling program. We now switch to the machine and mount the reference sphere at the first position. The temperature sensors of the 2 columns must also be attached to the base of the sphere. After sphere 1 has been probed with the master and slave machine, the sphere must now be moved to the next position. The further procedure is equal to the procedure with sphere 1. To complete the coupling, the reference sphere must now be positioned at position 3. The further procedure is the same as for sphere positions 1 and 2. The coupling is now completed. To check the double column coupling, go to CALIGO into Tools, Settings, and then to Duplex Coupling. If the coupling was successful, a coupling matrix called Global is created. The tab Created On is the date when a coupling was made with 3 or 5 sphere positions. The tab Updated is the date on which the double column coupling was updated with only one sphere. So what happened during this coupling process? Columns 1 and 2 have different origins. The origin of the master machine is located in the middle of the measuring plate. The origin of the slave machine of column 2 is located here in the top left corner of the measuring plate. This means that the probing of the spheres by each column also results in different coordinates of the spheres. Now, however, the origin of the master machine is used as a reference, and the origin of the slave machine, here column 2, is shifted to the master origin. This results in a common origin for both columns. Now the double column coupling is completed successfully. That's it already with the tutorial. I would like to thank you for your attention and would be pleased to meet you personally at a ZEISS training session soon. See you there.